So let's start by defining actually what MATLAB means. So MATLAB, first and foremost, is an abbreviation for Matrix Laboratory. And if you think back to the first lecture of the course, when I was covering the course learning objectives and looking at them, and a lot of the objectives were related to kind of understanding concepts of numerical methods, knowing how to manipulate matrices and vectors and so on. And I said in that context that MATLAB was kind of a great programming language to work with within this class, even though it traditionally hadn't been used. And at that time, I said it's actually reflected in the name. So that's what I meant by that. MATLAB is just an abbreviation for Matrix Laboratory. Now, you might wonder what actually MATLAB is. So many of you either accessed a web application through MATLAB Online, or even maybe downloaded an executable file onto your machine and actually installed software. So first and foremost, it's actually an application, right? And we'll look at the various functionality and contents of that application in the next slide. But in addition, it is a programming language. Now, when you think about its nature, it's predominantly numerical in nature. It doesn't have a lot of symbolic manipulation capability. So when you think about, we're talking about computing, and we call it computing basically using computers in order to solve problems in computation, which is just a fancy way to say mathematics. The predominant and traditional way of doing that is actually even to take continuous problems in mathematics and discretize them in order to work on a kind of a numerical basis. However, there are particularly more recently some computing solutions that allow you to do symbolic manipulation. And the example there that I'm sure that everyone is familiar with if you've taken a calculus class recently, and believe it or not, even back 20 years ago when I took my calculus classes, this same thing was done. It's just now that there's a cloud version of it, but Mathematica is the one that comes to mind automatically. And that's like if you have a function like sine of t and you want to compute its derivative or definite integral over some boundaries, having a symbolic manipulation is nice. Another thing that you should know about MATLAB is the same vendor which makes MATLAB, MathWorks, which we'll look at a little bit later, also makes Simulink, which is a very important kind of graphical-based system for graphical-based software, I should say, for doing system design. So things like in control and measurement and instrumentation. So Simulink is a word that you may hear. Just know that it's graphical and know that it's associated with MATLAB. So the initial version, I thought this was pretty interesting, so I just wanted to say it, commercially was sold in the early 80s. The first sale was actually to MIT. There were 10 copies sold. And the software actually under the hood is written in C. So MATLAB is not a compiled language. We're not going to go into all of that detail now. It's an interpreted language, much like Python. And so there's actually two layers of abstraction going on here. We're coding in MATLAB. It's being converted in C, which is actually being converted to that machine code, as you saw in your initial discussion board this week. So it has widespread adoption. There are more than 4 million users worldwide, predominantly in engineering, but lots of applicability in both science and econ. And it's owned by a company called MathWorks, which is headquartered in Massachusetts, and it's privately held and has revenues of $1.25 billion in the last year. So a lot of market share associated with this. And always the rule of thumb is kind of just go to the web and go to a job search engine and look at MATLAB. And you'll see there's lots of opportunities open. It is a proprietary, not an open source ecosystem. So because of that, it's going to be more common basically in enterprises and verticals that have adequate funding to buy the software licenses. So very common in DoD. It also has very widespread adoption in aerospace, along with automotive, versus kind of more of your bleeding edge, I hate to even call it that, but more advanced tech companies often side with open source programming languages. And the analogy to MATLAB there is Python. Both are interpreted languages. Both are very high level. Both are very powerful. The difference between the two is Python is open source, so no cost or license associated with that. And everything in life has a trade-off. So since you're not actually paying for a license, and this has changed a little bit with the availability of notebook environments like Jupyter and Google Colab. However, in general, there historically a lot of work to get a Python environment set up versus MATLAB. You legitimately just install the application and a lot of the work is done for you. That's what you're paying for. So we call MATLAB an application and we call it a programming language. So let's just give a little bit of discussion to what a programming language actually is. And we're going to have an entire discussion on this a little bit later after we look at kind of evaluating the differences between programming language and assessing them in terms of their level. We talked about high level and low level languages in the overview, and that's just basically a measure of how far away the rules of the language are from the actual hardware. So programming languages, you can really just view them as some instructions that translate what you're trying to do to something that the machine can understand. But that's why I wanted to, in quotations there, I have high level and low level, just to really reinforce that concept in your mind, because it's very, very important for being able to understand the trade-offs between programming languages. But at the end of the day, all that a programming language is a way to translate what you want to do. So you're trying to do some routine. Maybe it's import data, maybe it's clean data, maybe it's plot data, maybe it's to execute this code block repetitively or conditionally. We want to do that. And we need kind of a language to talk between what we want to do and what the machine understands. And that's what a programming language is. So like any language, programming languages have rules of what kind of statements are allowed. And that is referred to as syntax. So when someone talks about a syntax error, that is just kind of view it in the English language as saying something that ain't grammatically correct. Right? That is just an invalid kind of combination of the individual symbols that we have, in our case, words, to put our language together. In addition, I should say, just to elaborate a little bit before that, in general, if you have a syntax error, the software won't work at all. Think about it like you're back in grammar school and you're just learning how to put together sentences and you say some combination of words that aren't allowed to go together and your teacher just cuts you off right away. They don't even let you finish the sentence. They say, hey, that's a syntax error. Hopefully they didn't say that. But they said that those words, they just can't go together in the English language. So depending upon whether you're working in a compiled or an interpreted language, we're going to be working in an interpreted language like MATLAB. When we put a little bit of code together, if we put together something that just is not allowed and we try to execute the code, we're going to get an error right away. And that's called a syntax error. We're just violating the organizational rules. However, what will happen, remember, we're trying to do something the way we understand it in our brain. In the kind of programming language is allowing us to a means to translate from what we want to do in our brain down to what the computer understands. Sometimes we can put sentences together, and you probably are like, oh, I totally understand this watching Henry talk in this video. You can put sentences together that are allowable. You can put the combinations of words together. However, the result isn't what you intended. It just doesn't make sense. And that's referred to as a semantic error. So these are always the tough ones to kind of debug. You'll get to kind of get a reflection of what bug means in this week's discussion board assignment. But that's where basically you put some code together and it runs. It just doesn't give you the intended result. So two types of kind of things to consider when you're thinking about a programming language. It's syntax, which are its hard rules for kind of combinations of symbols that you can put together, and it's semantics. Even if something is syntactically valid, it might not do what you want. It might give you a semantic error. So I know I repeated myself a lot in that slide, but that's like a really, really, really important concept. One of the few things that I guarantee if you go into this line of work, you will be talking about syntax and semantic errors for the rest of your career. So I wanted to look a little bit about the function of MATLAB. So I showed you the desktop version first, but the cloud version or MATLAB Online is the same. There's four kind of key areas that you want to keep in mind. The first is kind of here in the lower middle portion. This is just the command window. So we can enter code. So when I use the term code, I'm just going to be talking about MATLAB as a text-based language. Most softwares are. So things that I type from my keyboard, I can enter them directly into the command window. And if I hit enter, assuming that I haven't violated any syntax rules, MATLAB will interpret the code that I've entered and do what it's supposed to do. Now, the most basic type of code that you can enter in a command window is just basic numerical operations. So hopefully I have MATLAB open. You can see I actually use it. It's not, I'm working in my download folder now. You might feel like, oh, he doesn't really use it. But I use this a lot. So here's the command window. And if I just type in 3 plus 5, as you may expect, that is valid syntax. It's okay to take the operator plus and pass two numbers into it. And if I hit enter, this thing will do what it's supposed to do. And that function, we'll dive into this a little bit later, of adding, it's valid to add two integers, and the result is to produce an integer that follows our rules of addition. So the software worked in this case. So think about the command window as just something where you can enter valid kind of code directly, but you're going to enter it on a per line basis. You can also just think about it if you're ever using MATLAB as a calculator, which I do all the time. It's just your calculator interface. And it's very, very nice because, like, for example, if you think about computing the sine of 90 degrees, we'll talk about this built-in function here in a minute. You might say, oh, he made a typo. It's not SIND, it's just SIN. But in this case, the D is telling MATLAB that the argument that I'm entering is in degrees. And you notice that you can compute trigonometric functions on here as well. So very valid use of MATLAB just to enter kind of basic math into the command window. So that's what the command window is, where you can just enter individual code and execute it directly. You'll notice what I've written here, and even though we're going to hit this later, I'll emphasize it again. I've said commands are executed and outputs are displayed if not suppressed by semicolon. So what do I mean by that? Well, another trick you should know in the command window is if you just hit the up key, you can re-enter all the prior commands. You kind of get a history of everything that you've entered. So we know what happens when I enter sine D of 90 without a semicolon. I just get the value of the sine function at 90 degrees, which is 1. However, if I suppress that by a semicolon, notice that it looks like nothing happened. And what's happening, if you think about it, under the hood, the way the computer is working is not changing. It's just not sending that value out to you to the command window because the semicolon tells MATLAB to kind of suppress the output that's generated. You might ask, well, if you're using this as a calculator, why would you ever want to suppress the output? Don't you want to see what the result of the calculation is? That's true. However, the majority of the time, we're not going to be writing code line by line in the command window. We're going to be writing a block of code in some sort of text editor. We'll be executing the entire block. And if you don't suppress your outputs incrementally, you're going to get a lot of noise on your command window, and it's going to be kind of hard to follow. Second is the workspace. So you'll notice this says where current variables or corresponding values are displayed. So you can come over here real quick. I'm just going to do something to trick you real quick. So look at my workspace and just see there's stuff there. And on the command line, I typed clear all. And you notice my workspace is now empty. Now let me go back and make one of those simple calculations that I made before, like 3 plus 5. Notice two things. Notice that in the command window, I get, since I haven't suppressed my output with a semicolon, I get the echo ANS answer equals A. And in addition, up in the workspace, I get a variable that's denoted as answer, and its value is A. And we'll define what a variable here is a little more in a minute. But basically, this is just telling me in my current software execution workflow, all of the variables that I'm keeping stored in memory for the time being. In addition, if we go back to, so we talked about the command window, we talked about the workspace where we can see all of the current variables that are in scope. We'll give that a more formal definition later. We have an editor. This is just where I can, if I'm trying to write code that's useful, I'm always going to need multiple lines. I can put it together right here. Now notice that, so just to show you what that would look like. If I go back, let me just create a, since I hadn't saved this file beforehand, I was actually using this to generate a little bit of data for one of the other classes. It's kind of randomly adding noise to the force displacement relationship for a spring. But the way that in general you create a new script, if you're in the desktop application, is to click on the plus in the upper left. So say I just put the two commands beforehand that I've had in here. So let me do this. I think that's what we have exactly. So if you notice as I'm starting to type, lots of weird stuff is going on, right? I type 3 plus 2, the plus is highlighted. I type sine D of 90, and I'm kind of getting some autofill that's telling me a little bit about this function. That's the main advantage of writing code in some type of what's known as a IDE, or integrated development environment, that's specific to your language. It's smart enough to give you hints as you write. Could I simply write, hopefully I don't have this looks like I don't have anything in it. Just ignore what's written there for now. Could I write in Notepad the same thing? Yeah, right. I can type numbers. I can type plus sign. I can type anything into Notepad. But if you notice, when I type it into something that's not customized for the software, it's not going to give me those automatic hints that I would like and that I would expect. So we talked about the editor and its role. Here is the current folder. A current folder just tells me everything that's on my current path. And that will make much more sense when we talk about generating, entering code into the editor and saving it as files. So if you use the MATLAB Online version, that's totally okay. You'll notice your current folder is over here, your workspace is over here. Here is your command window, and the only thing that you're missing in this layout initially is your editor, but you can get to your editor by either clicking New Script or under the plus arrow going to New and selecting what's known as an M file. So naturally, MATLAB, the file extension that it uses to know that a file belongs or should be opened or interpreted by the MATLAB software is .m. So let's look a little bit about the idea of variables in MATLAB. And really, this isn't variables in MATLAB, it's variables in any programming language. So when you talk about what a variable is, and think back to probably when you learn to use a graphing calculator. Oftentimes when you're making, so this is all about computation, because we're looking at computing for engineers. When you're making a computation, there's some value that you want to store in order to use later. So from a software point of view or a programming point of view, what do you need? Well, you need a place to put it in memory. So fundamentally, a variable is kind of a variable is an allocation within memory that you're going to use to store your value. Now, you could talk and get into the idea of RAM and how you address RAM, and maybe we'll do that a little bit later when we get into the computer architecture portion of the course. However, we don't have to keep track of where it's at. We don't have to think about, okay, I'm going to store some information there. How big does it need to be? That's one of the nice things about a high-level language, right? We just know what's in memory, and we just assume that we have enough memory that we can store everything that we want. We don't have to keep track of where its address is. Rather than address it with respect to where it's physically at, we're going to address it by some sort of symbolic name. So those are the two things that make up a variable in any programming language. Or its abstract location in memory. It's abstract as long as you're not programming down an assembly language where you actually have to tell it where to put it in memory. And the symbolic name that you are going to use to refer to it as. And the rules on that name will be dictated by the syntax of your language. So you might ask yourself, well, how much space should I allocate in memory to store my information? Well, it's just like parking a car in the garage. How big does your garage need to be? Well, it depends on how big your car is. So in this case, depending upon the type of data that you're allocating, that will determine how many bytes of memory are allocated to store your variable. So there's simple, very compact forms of information, something like an integer. There's more expanded or higher precision forms of engineering, like something with a decimal. That's called a floating point number, in case you're not aware. And there's not even numerical type of information. It could be what's known as a string, which is just a concatenation or a collection of letters, which are stored using what's known as an ASCII code. So again, everything under the hood is just going to be some binary number in memory, but the amount of bits that you need, and we don't even talk about bits, because remember, a bit is a very kind of low capacity unit of storage. We're going to need a lot of them, so we talk about bytes. So how do you declare a variable in MATLAB? Well, here is the syntax or the rule you use. You pick the name that you want to refer to for your variable, and you use the equal sign. We're going to set that name or that symbolic kind of ID equal to whatever value we're assigning. So here, let's go into a little bit more detail. The variable name in MATLAB, the syntax says it must start with a letter. And then after the letter, it can have any letter you want, any number you want, and even an underscore. And the value of underscores is to kind of mimic how we would write spaces within natural words that we were writing. You'll notice that anyone that's a little bit older, when they name their files, even though now on a Windows operating system, you can have spaces in your file names, they won't do that because historically, when working with computers, when you have an identifier, you don't want to break things over spaces. A space kind of delimits and signals the end of a name. So variable names are case sensitive, meaning CAT is not the same as capital CAT. In general, when you're picking variable names, you can pick whatever you want. You want them to be descriptive. However, the key thing is they can't conflict with something like a keyword. That's gonna cause some issues. So we already know, well, what's a keyword? Well, what if I named a variable SIND, S-I-N-D? You saw a little bit earlier that that's the name of a function, right? That's going to cause a little bit of what's known as scope conflict when we're actually using that name. Remember, the whole job of the MATLAB interpreter is to take what we've written according to the rules of the programming language and tell the computer what to do. So we don't want to confuse it. So we want to avoid kind of aliasing, which is using the same name for multiple things when we pick our identifiers. Variable value is any valid data type within MATLAB. So that can be a number, it can be a string, and so on. So what's interesting about MATLAB versus other languages, if you've coded before in maybe C or C++, those are strongly typed languages, which mean that when you declare a variable, so this is called declaring a variable, you have to tell it what type of variable it is. And remember, the type of variable will determine how much storage it allocates. So MATLAB will automatically determine what the type is based upon the variable value. So let's look at a little bit of an example problem. Ignore this syntax here. I took this from this example problem from another course that I teach. We want to enter the following command into the command window of MATLAB 3.4. Notice these square brackets. Notice we're going to terminate it with a semicolon. After executing the command, we want to explain how the workspace is modified, and from the examination of the workspace, determine the type of the variable, and then do something else and see what's going on. So let's do that, and I'm going to go and do this in MATLAB Online just so you see. So I think that's what we were asked to enter. Notice the workspace before I do this is empty. Notice that once I do it, it's populated. It's telling me in my workspace, I have a variable A. It has a value that's equal to what I entered, square bracket 3, semicolon 2, and it has a size of 2 by 1. Now, I didn't intentionally tell you what the square bracket is doing and what the semicolon is doing because I wanted you to look at what goes on in the workspace. And you notice this is pretty similar to what would happen if you did it. Just I want to make sure before I say that for sure. In the desktop version. Only difference there is you don't naturally see the size. You have to double click on it in order to see the size. So note that size is 2 by 1. Well, think back about what we talked about in last week's lecture. We talked about how when you have matrices, they're naturally defined by a number of rows and a number of columns. So when you think about a 2-row and 1-column thing, you think about a column vector. So what must be going on here? Well, in the MATLAB syntax, when you put square brackets, that must be telling MATLAB, hey, what I'm going to enter in, that's all a combination in general of values in a matrix. Remember, a vector is just a subset of a matrix. And whatever first number I enter, that's going to go in position 1, 1. Now, what must have happened here? Because if you notice, it formed a 2 by 1 vector. When it saw that semicolon, it must have told it, hey, rather than go to a new column, go to a new row. So that's kind of your first introduction to MATLAB syntax. When you enter a matrix, enter it in square brackets. And as you're entering the values, if you want to go to a new row, use a semicolon. The second thing that we were asked to do here is determine the type of the variable A. So notice that under class, so that's another word for variable type is class. And there's subtle differences. We'll talk about it a little bit later. You'll notice that this is storing it as a double. If you know anything about computer programming language, you might say that a double is something that's in general used to represent a number with decimal, with floating point precision. I don't need a double in this case. Each one of those entries into that matrix is small. It's just an integer. That's one of the things about dynamically typed languages. Since you're not telling it what type of data type to use, it will in general tend to be overly conservative and reserve way too much space. The last thing that we wanted to do, I think, was enter like for u equals some value. Maybe it's this. It really doesn't matter. The point of this exercise is to show you what's going to happen there. Well, if you notice, before it can even store the value within memory, it's giving me some text echoing back in red. This is the idea of a syntax error. And whenever we get a syntax error in a modern programming language, we can read the error and just see what's going on. And it's telling me invalid expression. Well, think back to what we said for our rules of variables and notice that variable names by definition in MATLAB have to start with a letter. So we violated the syntax rules, and naturally MATLAB is telling us, hey, that's something that you can't do. So that's a first example of both syntax and the interpreter in the command window generating a syntax error.